Next curve.
So, hey, everyone. Welcome to Next Curve's RIC Webcast. And it's been a while, but we're back in 2023 with a new program and a series on key topics in the world of technology and innovation that matter. And so, happy 2023. I hope everyone is off to a great start this year. And today we're kicking off a really cool series entitled From the Radio to the RIC, with a focus on the state of OpenRAN and what we see may move the ball in 2023. And I'm joined here today by Earl Lum, who is a legend in the industry, right, Earl?
According to my own mind, Leonard.
Yeah, according to your website, apparently. And he's the president of EJL Wireless Research, and what I would call as one of, if not the premier research firm focused on wireless infrastructure. So, Earl, it's great to have you on, man.
Yeah, it's great to be here. Thank you.
Yeah. And so let me really quickly go over with our audience what we're going to be talking about in this series. Unless, Earl, you want to just quickly introduce yourself actually before we even get into the agenda?
Sure. For those that don't know me or my company, EJL Wireless Research is focused on infrastructure related research. We don't do anything regarding the mobile handset. And predominantly, the focus is on anything within the RAN or radio access network of mobile networks, specifically now as we're in 5G, whether it's below 6 gigahertz or millimeter wave technology, and kind of everything from semis all the way up to the antennas that are mounted out on the towers that you see out in the world as you're driving or flying or whatever mode of transportation you're on. So that's really the focus, and all of that is written and published by myself.
Yeah, and just so that the audience knows, I mean, you literally get your hands on these large radios, right, and infrastructure equipment, and you do teardowns. I mean, the reports that you do, the analysis you do, is like literally the nth degree, and I think that's important for our audience to understand. And one of the things that we're trying to do in this series is, take this knowledge, okay, this very technical knowledge that Earl has, and surface it up into a level that's digestible for folks out in maybe outside of the telco industry who are looking at, let's say, 5G and all these things that we hear about it, but maybe would be interested in understanding what actually is happening under the hood. And as they hear about OpenRAN, what's really the state of OpenRAN, and what is the level of readiness that folks like Earl, who actually are down there in the weeds, assessing the equipment and really having a practical and real feel for the state of technology and the art. So that's what we're really going to try to do here. And so here's what we're going to cover in this series. Number one, the first thing that we're going to start off with is, why is the RAN hardware harder than software? Okay, one of the reasons why we're going to explore this is because the OpenRAN community, especially over the last few years, has gone forward with this narrative that this is going to be a software-led thing. You've probably heard of software-defined RAN and vRAN, all this stuff. And so that's really why we're going to be talking about leading with this topic, actually. The second thing that we're going to talk about, and this is going to be this is going to be our second episode, is the state of the OpenRAN stack, and is it ready for prime time? And this is a prevailing question out there, and something that a lot of OpenRAN vendors contend with, because a lot of operators are telling them, hey, look, your stuff is not ready yet. They're trying to dispel that notion. And so we'll talk about that. It's like, well, are they ready or aren't they? And why? And then third, we will talk about software. Will it eat the RAN? Will it eat the RAN? I don't know. Or will hardware still matter? Right? And so we'll answer that question because I mean, right now there's a lot of talk that there won't be any differentiation in hardware. So is that really going to be true? So we'll talk about that, and then we'll close things off, the series off with playing the Squid Game in OpenRAN and the race toward scale. And the reason why we're bringing this up is because I kind of introduced this notion of, Squid Game as being an approach and a strategy that OpenRAN vendors need to embrace in order to really push the technology. It's not even a technology, to push the movement forward. Okay. And so we'll cap things off with that. And I don't know, Earl, if you think of anything else along the way as we're doing this series, and we'll add it to the list, and we'll have a 5th, 6th, 7th, or whatever episode, right?
Yeah, sounds great. Whatever comes up and whatever is deemed important that I think, or you think everyone should be aware of, right?
Yeah. So, hey, let's kick things off here. So why is the RAN hardware apparently harder than the software? Because, going back to what I mentioned before, a lot of vendors really kind of espoused and promoted this idea that everything's going to become cloud native. So the RAN is going to be software defined, and you can do all this stuff like, new ways of automating the network and orchestrating services across the network and network slicing XYZ. And lo and behold, as we got closer to deployments, even with Rakuten, right, there was this realization that, well, wait a minute, we don't have necessarily the whole portfolio to go to market and support customers with a full suite of 5G ready or capable hardware. And so, I wanted to get your thoughts. I mean, you're there down in the weeds with your clients, with the technology. What's your view? What have you seen? Because, you and I have been at a lot of conferences together, and, your thoughts.
I think if you look at the slideware of what OpenRAN is assuming, the assumption is that everything in the hardware side is commoditized, whether it be the storage, the memory that you're using, the processor types, all of that is standard off-the-shelf COTS from the PC world or whatever. And the only thing that really matters now, because everyone's on a level playing field for the hardware, is how well and efficiently can you code those tens of millions of lines or whatever that are in, or hundreds of millions of lines in the stack, right?
Right.
And one would argue that, sure, you can get all of that to work. But the question has always been, how efficient is it going to be? How optimized will it be? And if you're talking about a data center that's humongous, that has controlled temperature and every other environmental variable inside of it, then sure, that's fine, because you have infinite space power, technically, or the assumption is, and you don't have to worry about that. But the reality is that a lot of this stuff is going to be deployed at the edge, at the bottom of a cell tower, where there's a shelter that gives you maybe 9U rack space of room to put all of this stuff in, right? And the radio is still sitting out there no matter what you do with the digital side and the baseband unit and such. So now the question becomes, you don't have infinite space, you don't have infinite power in this distributed RAN architecture that the world is still mostly operating under for 4G and even for 5G when we were deploying non-standalone, right? So now the question is really one where the incumbent operators have a set amount of space, power that defines exactly what you can place there if you want to replace it with something new, whether it's OpenRAN or something from the existing incumbent equipment suppliers, right? If you don't fit into that form factor, as an example, you have a sled that's for a data center. That sled probably is 6 feet deep. There is no 6 feet deep slot in the shelter of the bottom of the macro base station tower. You typically have 2 to 3 feet of depth. So now what you had for a data center no longer fits into the macro cell tower for that configuration. So the hardware now has to be reconfigured. You can't take an off-the-shelf server that's 6 feet deep. You need a modified server that's now 3 feet deep, as an example. One would argue, well, the Ericssons of the world would argue that our ASICs are optimized for every single function that we do. Right. So the power that we consume is going to be the least amount of power that anyone in the world is going to have available to them, as opposed to a very standardized and non-optimized processor solution that may be from Intel, or maybe it's more optimized from Marvell, but they're still not going to be ASICs, right?
Right. Yeah, and I think you're making a really good point here, and it's something that we kind of touched upon before we hit the record button, is that the different chip architectures, right, and approaches. And that, a lot of the incumbents that are the big guys like Ericsson, Huawei, et cetera, I mean, they are using ASICs. And when you look at, like, for instance, Intel announced their Gen 4 Xeon processor. And, in the x86 world, there's a lot of talk about chiplets. And, the thing about chiplets, though, is that that architecture, you're looking at a lot of interconnects happening between smaller die that might be, implemented on a chip. With the ASIC, I mean, it's an ASIC, right? It's
right. Everything is on the one piece of silicon typically, but now that definition of an ASIC is starting to morph, right? To where it's a system on a package, system on a chip, or all of these other words for a whole bunch of chips or chiplets that are all interconnected into one package. And when you lift the lid off of that package, there could be 20 or 30 die in there, depending on whatever you're trying to do, and not the traditional single piece of silicon that we used to have.
Right. And I think that's one of the things that if you're tracking how the semiconductor players are playing and evolving their products to pursue this market, one of the things that you're also observing is sort of the disaggregation. I mean, of the silicon at different layers of the network stack, right, or the RAN stack. And at least that's what I've observed. I don't know what your reaction to that comment is, but that's.
I think if we look at prior to December 2021, when Marvell announced their full end-to-end solution for OpenRAN, so that you can go from the baseband unit, layer 1s, 2, and 3, all the way through the optical fronthaul into the radio. Up until that point, there wasn't a way for a ORAN vendor or OpenRAN vendor to have an entire chipset solution from end to end, which meant that your requirements from an engineering perspective were much, much higher to integrate in all of these disparate solutions from different players to be able to get it all to work into one system. Now, at least from Marvell, you can get everything up to the optical interface. And then with the partnership that they announced with Analog Devices, you can get all the way to the RF side. Now, that still doesn't mean you're done, because you still have to design the transmitter and the receiver. You have to design the antenna if you're talking massive MIMO. And so none of that is a build to print file somewhere that someone's going to give you. So you may have solved the silicon side for the digital and the RF, but you still have to figure out, how do I get this into the real world from off the board where I generated the signal? And how do I receive it from the real world through an antenna radome and through an array of a bunch of elements, and then have all of that hopefully coalesce into this signal that you can decode and get it back into the baseband unit? So That's why the hardware remains very complex, because you have 5 or 6 layers of it. It's not just, I just populated and stuffed the PCB and I'm done.
Right. And so there, I mean, yeah, if you thought the software was hard, I mean, geez, I mean, listen to what you just said. That's a lot of engineering, optimization that has to happen across a very complex system, right?
And a lot of expertise that may not exist outside of the traditional incumbent equipment suppliers, and the amount of man hours or people hours that you would need to be able to achieve something that not only just works, but it works at the most efficient level that it can. And that only comes with decades of experience in designing this. And then I'd also throw onto that pile, if you're in the OpenRAN community, you may not get access to the most advanced semiconductor chips out there because your volumes are so low that no one's talking to you, right? And you're trying to buy through distribution or something. And so Ericsson's going to get access to technology at 3 nanometers, and you're getting something off the shelf at 10 nanometers or something.
Yeah. And I think this is something that we have seen a lot of the OpenRAN vendors really take to heart, especially the originally software-oriented ones, right? Like Mavenir and even Parallel Wireless. At MWC 2022, we saw them make forays into the radio, and Mavenir has their Open Beam portfolio, right? Which they started development on, I think it was like 2 years ago. But we saw that at their Analyst Day, right? I mean, they gave us a tour and went over their portfolio that ranged from small cell all the way up to massive MIMO, and then look at what Rakuten's doing, with the SIMware. Right. And so there's this acknowledgement, and I think a growing acknowledgement, that it's not just about software. There has to be a lot of attention to, quite honestly, what's ending up becoming purpose-built. The whole idea was to move away from purpose-built, but some of the components.
Right. You need accelerators now in these servers, right?
Right. Exactly. Which is the super ironic thing about what's happening. I think it's just a result of a wake-up call as these deployment opportunities came to the door with a lot of the geopolitics that's been happening, especially with the banning of the Chinese vendors in the U.S. and some countries in Europe. It's just a bit of a result of a rude, sort of a rude awakening, if you will.
I also think if you think about the number of SKUs on the digital side, you have your core network, you have your baseband unit software and such, and it's pretty much well-defined, and there's only one flavor of it. Once you get into the hardware, every frequency band, every output power level, every MIMO configuration is a different SKU. And it starts to explode on you in terms of management, R&D teams that have to develop each one of those individual SKUs for depending on whatever the requirements are for that particular network. And now you have exponentially increased complexity on the hardware side, because you're not just making a vanilla one flavor unit that does everything in the network. You have to have 20 or 30 flavors, or 31 like Baskin Robbins. And that takes an incredible amount of money that a lot of these vendors don't have that are in the OpenRAN community.
Yeah. And that's why, when we end this series, it's going to end on the whole Squid Game thing, and if you don't know what Squid Games is, you have to go and watch it on Netflix. This isn't a plug for Netflix, but just watch it and then you'll really understand. You have 3 weeks to get up to speed on it. And so, I want to end this segment, or at least this episode, with sort of an analogy, a simple analogy for our let's say less technical audience that's looking at this rather technical topic of OpenRAN. But really quickly, I want to say OpenRAN is not technology. Okay, I want to put that out there. It's just a set of standards. Okay, and then it's architecture decisions. It's a not a technology. And, if you argue against it, that's fine. I don't care. You can just make your comments in the comments section. And Earl, if you disagree with it, you can tell me I'm wrong right now.
No, I'm going to agree with you, Leonard, in that it is a set of standards and specifications. And then how do you implement that using the correct technology becomes a differentiator for each and every one of those vendors.
Right. So everyone out there, stop calling it a technology. You will be better for it. I think bottom line is what we're looking at here is with any open standards versus, let's say, proprietary or purpose built, or if you want to call it incumbent, one of the best, I would say, analogies to use would be Apple versus, let's say, a supposed open Android ecosystem, right? Or even, call it PC versus Mac, and one of the reasons why, Apple continues to put out highly performant devices out there is because they have an integrated, optimized stack, not meaning just software. It's an entire system stack that has been integrated in a very highly optimized way. And we kind of touched on this before we pushed the record button. But do you want to add any color to that before we close out this first installment of our series here?
Yeah, and I think a really good analogy that Ericsson, as a long-time vendor in the RAN space, all the way back to the beginnings of analog for wireless, has stated is that you can't do everything 100% hardware and you can't do everything 100% software. Yeah. And the question is, where is that split in percentage is realized after decades of research and know-how and understanding how to fine-tune things to where, depending on the situation, it may be 48.5% software and the rest being hardware, or it may be 35% software and the rest being hardware. It really depends on what is it that you're trying to do and solve. And so the belief that you can do everything in hardware is false, but conversely, the belief that you can do everything in hardware is also false.
You mean software, right?
Software, yes. Software, okay. 100% software is wrong, 100% hardware is wrong. Yeah. It's a subtle mix of the two that you have to get right.
Yeah, it basically what it boils down to is optimized system design.
Exactly.
That's what I mean. So this whole software versus hardware thing is complete nonsense. It has been from the beginning. This whole notion that software is eating the world, eating the RAN, eating the everything is also, it's not a healthy notion. I think the way we have to think about things is that, software needs optimized, efficient, sustainable hardware to run on that
Absolutely.
Is performant. That is how we need to think about stuff. And I think this is something, thankfully, that the OpenRAN community is starting to realize. And, there are, I'll have to give hats off to Rakuten. They've been sort of a pioneer on this, although, they have, they have had to take a bit of a, let's say, purpose-built, hey, we're kind of pushing things forward. So we have to do some custom workarounds to make OpenRAN something that is viable and can now, run or be the basis of the networks that they're running in Japan right now.
Right. And I also think, again, one final note in terms of the hardware, if you look at the current ecosystem for the OpenRAN community, it's extremely heavily weighted on the radio side and very upside down when you look at on the digital and on the baseband units and the DUs and the CUs. There aren't a lot of vendors that are there in that segment. So that makes it a lot more difficult because the radio guys know how to do radios. The baseband people know how to do baseband, and merging those two together is not always simple and easy to do.
Yeah, I mean, that's a great point to top off our session here. And man, That was good. I really enjoyed our conversation.
Yeah, I enjoyed it too, Leonard. Thank you.
Yeah. And so to our audience, I hope you found this session informative. I surely did. Just continue to follow us. So subscribe to the Next Curve YouTube channel. You can find us at www.next-curve.com. Also, make sure to look up Earl. I mean, especially if you're a hardcore, you're looking for a radio design, for example. This is the man.
Or someone else's radio.
This guy is like hardcore. My job is to take all that detailed techno mumbo jumbo that he knows and then surface it up in a way that is palatable and digestible for a diverse audience that's very interested in this topic, but may not have the technical background to absorb or even understand what happens underneath the hood. So thank you so much, Earl. And we will be back.
Thanks for having me, Leonard.
We will be back.
We will be back.
So yes, stay tuned and we will see you in the next installment of what are we calling this thing? From the radio to the RIC. Let's do it together. From 1, 2, 3.
The radio to the RIC.
There you go. Take care, everyone.